Welcome back to ECD Laboratory, second semester Diploma in Electronics and Communication. This is about session number 2. In session number 1, I had explained about the passive component, resistor, capacitor and inductor. In the experiment 1, we have discussed how to find the value of the respective component, resistor, capacitor and inductor with the help of the color code and with the help of the printed character on the body of the resistor, capacitor and inductor. So in this video, I'm going to explain about electronics instruments used in our laboratory. There are two instruments we used in our laboratory. One is called as an multimeter, another is a LCR meter. See why we need multimeter and LCR meter. These are all the two instruments we use to measure the electric parameters. What are the electric parameter? Voltage, current, the resistor, inductor value, capacitor value, and we need to check the continuity of the wire, and we need to check the whether devices are working or not. All these things can be done with the help of this two meter. This is a very much necessary while doing our experiment, and we need to study the behavior of our component while applying some voltage, how it will going to behave. That behavior can be studied with the help of the multimeter. See, multimeter is used to measure the voltage, current, and it also finds the continuity error. There may be some discontinuity connecting point from one to another point. There may be wire damage. That continuity error can be found with the help of multimeter, and there may be evaluate the component. With the help of multimeter, we will be able to find the diode, transistor, whether it's working or not. That can be detected, and that is a very interesting things one. And it able to find the value of resistor and capacitance. Multimeter cannot be used to measure the value of inductor value cannot be measured, and some low cost multimeter will not be able to measure the capacitor value. For this, there is a different device. This multimeter can be broadly categorized into two types. One is analog multimeter, another digital multimeter. In analog multimeter, there is a needle, and the needle will be deflected based upon their values. There is a connecting point. There is a plus means it's a positive, and black means it's a ground. We will be able to connect the two probes. With that two probes, we can measure the DC voltage. DCV means it's a DC voltage, range from the 10 voltage to 1000 voltage, and there may be AC voltage also. You can measure from the 10 to 250 voltage, and you can measure DC milliamp current also. It's a 0.5 to 500 milliamp current, and we can measure the resistance value 10 to 1 kilo ohm. This means up to 1 kilo range. We can measure the resistance value with the help of this meter, this analog meter. We can able to measure DC voltage and DC current and AC voltage and resistance value. These are all the functionality given for this analog meter. Here there is a different scale also. You can see the color code represented. Green means it's a resistor value, and red means it's AC voltage, and white color means it's a DC voltage and DC current. So what is the drawback for using the analog multimeter means we cannot able to actually read the accurate result. Means needle will be deflected from in between 100 to 110. It's highly impossible to predict whether it's a 101 or 102. That is the problem. Its accurate result will not be able to get in a analog multimeter. To avoid that, there is a concept called digital multimeter. In digital multimeter, the digits are displayed. They're like you can see here 0.00, 0.0, no, here 3.001. Means with the help of the digit number, we can accurately measure the value. That's why they called as a digital meter. Digitally displayed value on the display section of the multimeter. There are 4 different section of the digital multimeter I have shown. This is the basic version, and this is the cheapest version. You can find it around 300 to 450. You can find this is about a basic version of digital multimeter. This is sufficient for to do our lab experiment also. There are some better quality. It's more than 500 to 1000. This is a somewhat good quality compared to this one, and there is a larger value. There is a multiple function also. With this, we can able to measure the capacitor. See, if you see here, there is no capacitor value, but this multimeter gives the f means it's a capacitor value also can be measured, but it was costly. It's around 2000 to 4000 value. There is a more costliest high quality digital multimeter is available. You can see how it looks. So these are all the different version of the multimeter available in market. You can take any one to do your lab experiment also. We have in our laboratory, we have all these three up to some good quality of multimeter is available in our laboratory. So this is about a different section of the multimeter. The first section is a display. A display section displays the value and input. This is about a connecting point. They also called as a socket. There are few multimeter have 3 sockets and few multimeter have 4 sockets. Depends upon the capability of the multimeter, how they are designed, and the manufacturer, how what are the features they are given. Based on that, there may be a 3 connecting point or 4 connecting point. The one common connecting point is called ground, that is represented as G and D, or like this they can mark. This is about a ground. And the one point will be represented as a positive voltage. The V means it's a voltage measurement. We have to use ohm here, ohm indicated. To measure the resistance value, we have to use this one. And this is a different point. The written like ampere, DC ampere, and value they have written. This is about input terminal, and there is on off switches. Here we can switch on and switch off, and display section, and we can switch either DC or AC. And this is a range selector. Different range of value is available while measuring the here the basic question of multimeter. We can see it's a off switches. If you rotate this knob in either in clockwise direction or anti-clockwise direction, the LCR, this digital multimeter will get on, will switched on, and you can able to measure the value with respect to the modes what you are going to adjust. See, if you till the knob here in this V section, this DC voltage, we can measure DC voltage up to 200 millivolt to 1000. And if this knob is set from this 10 to 2000, it's a AC. Sorry, DC current. That means it's a ampere. It's a DC current. We will be able to set 10 to, it's a 2000 microampere to 10 microampere. And AC voltage, it's a maximum AC voltage we can measure 750. Like this ohm means it's a resistance. This is a ohm meter. This is a ohm meter. And this is about transistor testing. We can place the transistor. There are 2 type of transistor, NPN and PNPN. There are emitter, base, and collector. We can place it here, and there is a point called HFE in the transistor. See here, if you rotate this knob here, HFE mode, you will be able to find the gain of this transistor. And there is a 3 connecting point. There is a one is a negative, that is a common, they represent COM, and a positive point, and there is a 10A max. That means if we want to measure the current of more than 1 ampere or more larger the current, we need to use this point and this common point. And the mode is set here 10 ampere current. So this is the multimeter, different knobs and different section. And this is about the range. What we have seen here, this range selector, we can, each multimeter have a different range selector. This dialing knob we can rotate, and we can set the ranges. Different ranges are available. And for connecting this, we are going to use the probe. This is about 2 LEDs inbuilt in box. They are, while purchasing the multimeter, they provide this 2 LEDs probes. This probe have a 2 point. One is a 2 LEDs. This can be used to connect it to the multimeter point, and these 2 LEDs can be used to measure the value across the circuit. So like this we can connect here. We can see there is a multiple range section here. COM means it's a COM, and V ohm and diode. We can, with the help of this, either we can measure the voltage value, or we can measure the resistance value, or we can test diode. So this 3 operation can be done. If you want to measure the current of milliamp, we have to connect positive to here, and this is a common. And if it is more than larger the current, we have to connect the positive here and common. See, like this we can use different socket point for a different value measurement. It's available in multimeter. And using the multimeter in lab, we will going to measure the resistance value. How we will going to measure the resistance value, we will see it in a practical section. So this is the setup. While measuring the resistance, the multimeter has to set at the ohm mode. That is called ohm mode, means it's a ohm meter mode. And you need to connect the COM, black wire to common, and red wire to V ohm section. And the other end of this has to place at the terminal of the resistor value. It provides the ohm resistance value. During this we need to select the range. The resistance range from 200 ohm to 20 ohm. It's all depends upon the resistor. This is called manual range selector. There are some multimeters available. We can auto select the range also. And while measuring the resistance, we cannot use our hand like this to measure the resistance, because it will not going to give the accurate result, because our body is also having a inbuilt resistance. That resistance will be added to this device, the resistor. It gives the wrong value. So this is the way we cannot measure the resistor value or capacitor value like this. We have to place the resistor of any insulator table. We need to place somewhere in the breadboard or somewhere in the table, and we need to touch this two lead, not with our finger, with these two leads. Then only we can measure the actual value of the resistance. This is about multimeter. And we can measure the voltage also. For voltage difference, we need to set this knob into V. If you are measuring the DC, it's a direct, and if you are measuring AC, we need to set the voltage knob into an AC, and we can place positive and negative, and we will get the voltage. And while using the voltmeter, voltage, if you are using the multimeter as a voltage measurement, we need to place this voltmeter as a parallel. Means it's a parallel to the component. Whatever the component is there, we need to use parallelly. That's why we can then only we can measure the voltage. And if you can measure the current, this multimeter, if you set as an ammeter, it should be series. It's series with the respect to here positive and negative like this. But in previous section, it's a positive and negative. It's a reverse. This is a parallel section. Like this, we have to use the combination. Voltmeter is a parallel. Current meter means it's a series combination. And if you want to set the diode checking, you can place this meter knob into diode, and we can place the red positive into anode and black into cathode. It will display the diode breakdown voltage. This way we can do diode checking. We'll discuss it in coming section detailedly about how diode can be tested. And there is a one more meter we used on laboratory, that is called LCR meter. L means it's indication of inductor, and C means it's a capacitor, and R means it's a resistor. This meter is capable to measure only the three parameter: inductor, capacitor, and resistor. Multimeter cannot be able to measure the inductor value. That's why they come up with another device called as an LCR meter. This LCR meter have a three section. LX means it's a inductor value, and F represents it's a capacitor value. You can measure the capacitor value, and there is a ohm represent the resistor value. This LCR meter is similar to multimeter, but it's have a different connecting point and different range selector also. There is on off switches, there is a LRC switches section and connecting point. If you want to measure LX, we have to use this one, that means inductor. And if you want to you measure the ohm and diode, we have to use this 2 point. This 2 point is for resistor and diode, and this 2 point is for L and F. This capacitance and inductance measurement, and this is a range selection. See, this is about inductor from year to year. And see, this is about micro Faraday. That means from year to year we can measure the Faraday. And HFE, there is about transistor testing. Here transistor testing is available, and resistor value and diode test. These are all the features available in LCR meter. With the help of LCR meter, we can measure the inductor value. How we are going to do this? Slide gives a explanation, is self-explanatory. First, switch on take a inductor value and place it on a table, somewhere insulator table, and switch on the LCR meter. While when we switch on LCR meter should display 0. Otherwise, you have to reset and connect the two LEDs the respective section. One is common, is a black one, and the red is a positive one, and set the range knob, that is a dial knob, to the inductor section L, and set L have a different range also, depends upon the value. We can set this range value and place the inductor value terminal, positive to the inductor terminal and negative to the inductor terminal. It displays the values. There is simple, there is it's not a difficulty thing. Only difficult thing is to select the range. Appropriate range selector is required. See how you can identify the appropriate range means, whenever you come up with a lower value, if you select a lower range but your inductor is a higher range, it will display OL or some dot 1. See, like this it will display, that means it's an infinite value. At that point what we have to do, we have to increase the range. If you keep on increasing the range, at one point we will get this kind of value. It's represented the it gives the actual inductor value. So this way we can measure the inductor value. At the same time we can measure the capacitance value also. Same procedure, but only thing we need to select the capacitor dial knob. Like this we have to use. Thank you.